Hello, let's place dominoes. It's time for some pips. We've got, as usual these days, one Ian puzzle and two by Rodolfo. We'll start with the easy puzzle. Let's get solving. Let's start solving, I should say. All right, we need three of something. What do we have that meets that criteria? Criterion. We've got three fours, so we need a greater than 0 pointing to a 4, which would be a 3. That's the only possibility there. Then a greater than, wait a second, no, sorry. This one goes in the greater than 2. The greater than 0 is just the 1 4, sorry. Because then we can use the 3 there. And then we'll put a 0 4 here. And then we need 2 of something, which are 5s. So we'll put the 0 5 there and the 2 5 here. And that's the easy puzzle. Let's try the medium. Okay, we need greater than 2 connected to a 5 or 6 because that's what goes into 11s. Look how many 6s we have. We have 4 6s, so we could still put the 6s in the 3-sized equivalence region. We've also got 2s that could maybe go in there. Actually, they couldn't because we need we need a double to go in that area, and it will be here because if I'm just putting anything in here. If we put, dominoes there, we'll need one domino here, so that forces where the double 6 goes. Okay, so that's that. And then we need a third 6 that points down into an inequivalence region. Well, the 5 goes here. This we know, because we need a 5, 6 in the 11, and we can't put it here because then the 1 breaks the greater than 2 requirement. So that goes there. That's straightforward. And then sorry, the 6 has been forced ever since we put that double 6 in there because we need the other half of the 6 to have greater than 2, so the 3 goes there, that's fine. So now the remaining 6 goes here, that's fine as well. We now need less than 2, which is a 1, so that goes here, that's all we have. Oops. And we can't put a 0, 1, or a 2 in here, so it'll be the 3 or the 4, and actually we need the 4 to be greater than 3, so that goes there, and the 3 goes here, and that's that. That's the medium puzzle. Let's try the hard one. Okay. We need 4 of something for this equivalence region over here. Threes could be it. 5s could be it. 5s might be, well, I was going to say 5s might break that 15 region, but that's not true because we could make that out of 2 6s and a 3. Although, no, we can't use 5s because we need a double something for the corner. So 3s it could be, or 2s. No, we don't have enough 2s, do we? So must it be 3s or 1s? No, we don't have enough 1s either. Okay, I think it needs to be 3s, and it has to go here. So then we need, well, I was going to say we need 3 pointing to something we have another of. We don't necessarily, well, yeah, no, we could put a double thing here. Okay, I don't know what goes here yet. Actually, this is very unclear because look at that. The other 3s in this equivalence region, they could both point into voids. So there's really not very much constraint there at all. Okay. How do we, okay, let's look at what we need 3 of. So that could be 2s or 1s or even 5s. No, it couldn't be 5s because it needs to be something we have a double of because otherwise we'll break this 10 region. If we were using 3s, which we don't have a double of, we would need to then have 3s go in here and we immediately wouldn't, well, sorry, never mind. I was thinking of the 10 region as an equivalence region, but I did this as an example and it actually just worked. It was correct. Leave that up to 10. I'm not saying I think that makes it correct, but it might be. I mean, it might be correct. And that was weird. Actually, no, never mind. Sorry, that was never going to be right because we need 3s over in the 4-sized equivalence region. Sorry, this was my example to prove why this doesn't work. And it doesn't work, but not for the reason I was using to prove it. It doesn't work for a totally different reason. which is that we need 3's over there or elsewhere. Right. Anyway, so what do we have 3 of that could work? 1's, 5's, 2's. Okay, let's see if we can do it with a different thing that we don't have doubles of, just to see. So those would be 5's in this case. Do we have 5's connected to things that could add up to 10? Actually, one of them could point down anyway. You know, we could put one of them down here. They wouldn't even all need to point across. Yeah, I mean, it looks like there are ways to do this. This particular thing wouldn't work. This particular arrangement would not work. This one might. This would, in theory, work. Because we could put a 4 there. Now we've got 10. Now we've got 9 in the 15. So we could finish the 15 with another 6. And we could make an 8 with a 5. I mean, this might just weirdly work. Like, oh, no. Sorry, we need a 3. We need both 3. We can't use any 3's for anything. Yeah, that actually doesn't work. But it doesn't necessarily work for a sort of... It just kind of works because I tried some stuff and it didn't work. It doesn't really prove anything. I was just taking a kind of wild stab. Okay, I need to think of a better way to make these things work. Should I be adding up? I don't want to do that with this many indeterminate cells. How do I make this work? Do I need the 15 to be 3 5's? It could be 6 5 4. I'm not sure how to be thinking about this. I'm sorry. I just don't have any good ideas about how to solve this particular puzzle. What about the 3's? They just feel so unconstrained because, you know, half of it goes into nothing. Maybe I think about okay, if the equivalence region were a 6, that there'd only be one way to do it, and it would be this. So that's fairly constrained. Then the 15 would need to be all 5's, and that does seem a bit tricky. Is it? Actually, we would then, I mean, we'd have both we have a 5-1 or a 5-2 to point up into this equivalence region if we want to do that, so that's not very difficult. Although, it's actually, in this particular case, it's not very difficult to, or it is difficult to create the 10, but that's just because of the way that I happened to orient this. That's not necessarily even correct. This could be a 5-2. I don't know if that makes any difference, really. I don't... Well, then I would need this to be here, and then I couldn't solve that. Maybe it is difficult to make these with all 5's. Is there another way to do this? I'm just not sure how to think about this. I'm very sorry about this. This way does feel more difficult, but I might have been missing a possibility as to how to do it. How does this work? Oh, I'm almost at 10 minutes and I've not really done anything on this puzzle other than put that 3 there, which was pretty obvious. I'm just not sure what to look for here. Okay, what about ways to make 8? Is that constrained at all? 6 2, 5 3. We do still have one extra 3 to use, so even that's not constrained. Or double 4. We've got all of those possibilities. If it were double 4, we'd need a 5 pointing in some way into the 15, which again doesn't seem very difficult. Actually, we could even put a 4, 3 in there. If this were then double 6, which couldn't work that way, it would have to be this way. Does that work? No, I don't think it actually, this doesn't work. That's such a small thing to rule out. Does it actually? Could I put a 6, 5 in here? No, it doesn't, because we've used too many 3s at that point. I mean, that doesn't work, but that's so minor. Like, that doesn't, who cares if the 4, 4 doesn't work with the 8 in that way? Does it work this way? It doesn't, I mean, it's just feel like I'm sort of messing around the edges. It must be making this 3 region, this 3-sized equivalence region work. That does seem like the difficult thing every time I actually get going. Now we need both 3s accounted for, so we can't use any other of our 3s. I don't know if they go this way. I'm just getting them out of the area down there. I mean, this would work with the 10, but now we've broken this equivalence region over here. I don't know if this means anything or not. I mean, the thing that I have right here doesn't work, but it was sort of arbitrarily assembled. So I just don't know if that necessarily, I don't know what it's telling me, I guess. No, this doesn't work at all. I don't know. I don't know if that means anything at all. If this were 5, 2, I think I tried all of this before. I just don't know what I'm doing at all right now. Sorry about this. I'm absolutely flailing. Right, let's just put the 3s in there just to get them out of the way, so I don't get distracted by them, because I think this is not, yeah, this isn't possible this way. Okay, I mean, I think it's probably the case that we can't put double 4 in this 8, but again, that just feels like such a small thing to demonstrate. It doesn't really seem like anything important. Maybe 5, 3 is also worth ruling out, because we do need, if we put a 5, 3 in this, we would absolutely need all the 3s. We wouldn't have any 3s left at that point. We don't have a double 5 or a 5 connected to a 3, which would make that actually tricky. We then need something like a 6, 5, and then 3 going elsewhere. I don't know. How do I make progress on this? I must be missing an obvious way this works, because I can't imagine I'm just meant to completely guess based on nothing at all. Nothing at all. If that were 3, 4, then that would be 4, 5. That would be the only possibility there. Is that useful? I mean, I don't know. I think I've determined at this point that the equals needs 2 1s or 2 2s up there. Is that true? Is there any other way to do it? Can I just double check that I'm not wrong about that? The only other thing that would fit up there would be 5s, I think. I don't think we have enough of anything else to be an alternative to those possibilities. So is there a way to make that work? If we put a 0 here, say, then we'd need 2 6s. So we'd need a 5 6, which we don't have. Do we have so now we'll just again get our 3s out of the way so I don't get distracted by them. This would, in this particular case, this would have to be 5 4. This would need to be a 5. No, this doesn't work. We don't have enough to make the 8 in any way. I don't know what I'm doing. This doesn't work because then we'd need a 2 in the 10, but you can't go down or across. I think it does need to be double 1 or double 2 up there. I just don't know how to figure out which. If it's 1s, then we need a 5 pointing somewhere, one way or the other. Oops. I don't think this works because we don't have we can't make 5 in a single cell. So if it were 1s, the 5 would have to be pointing down. What does that tell me? And I don't think we can ever make the 8 in a single domino. That's useful. I mean, I think that's obvious, but I've never quite consciously observed it. What that means is that this bottom cell of the 15 region needs to point across into the 8. That's what that would mean. So it's a 6, or it's a 2, or it's a 4. I think we determined we can't do double 4 over there. So it would be a 6 or a 2, and the other half of it would also be 6 or a 2. Is that helpful? I don't know. Now, the 10 pointing up could also be a 6 or a 2, or it could be a 4. If it were a 6 pointing up, we could have double 2 up here. Is that helpful? We'd then need a 4 to finish the 15, and we could put a 3 going across. Then we'd still need both of our 3s. Now, we don't have anything to make the double anymore if we've done that. What am I doing? What am I doing here? I'm doing nothing. This is horrific. If we put a 6-3 up here, we could then finish this with something that adds to 7. Don't know if that's helpful either. We then still need a 4 in the 15 pointing across, which would, I guess at this point, have to be the 5. So this would need to be a 3. That's wrong. Oh, no, this never could have been true. We need our 3s over there. Oh, I'm achieving nothing. I've probably come close to the correct solution any number of times. People sometimes play. This has happened less frequently recently, but it used to be the case that I would constantly be butting up against the right answer, and then I would just, give up and make a mistake elsewhere. So I wouldn't be surprised if that were happening right now. This could be a 5-1. We could put 9 up there. And I need to remember I'm always still going to need 2 of something that isn't 3s to go in this other area, which looks like right now it would have to be 6s. So this would have to be something like this in this version of reality. This is already wrong because now we can't make the 15. Oh, no, never mind. This could be 1s. Although this doesn't work either, because we'd have to put the 5 going that way, and now we don't have a 2 for the 8. Maybe I will add these numbers up. I don't know what else to do. I'm really sorry about this. Okay, so the 4-sized equivalence region is always going to be 3s. So that's equal to 12. And then we've got 12 plus 8 is 20, plus 15 is 35, plus 10 is 45. So we've got 45 in the regions that we absolutely know about. How many total pips do we have? 6, 7, 8, plus 11 is 19, plus 6 is 25, 29, 38, 45, 48, 55, 64. I think we have 64. Maybe this is actually useful. So we only have 19. I mean, that's not actually that small of a number. I think we have 19 left to play with in terms of the 3 void cells and the unidentified equivalence regions. So I think the equivalence region is going to be 1s or 2s. If it were 2s, that would be 6. So that would bring our remaining cells down to 13. I think that, let's see, actually, could this equivalence region ever be 6s? That would be 12. We'd only have 7 left to play with. So this would have to be 1s. No, there's no way that works. No, there's absolutely no way that works. Is there? So 19 minus 6 is 13. Wait. Sorry, I'm losing my mind. 19 minus the double 6, which is 12. 19 minus 12 is 7. Minus, we say 3 here. That would leave only 4 to put in these other cells. Yeah, I don't think that works. I mean, one of them could be 0. One of them will be 0, definitely. Maybe that's fine. Well, maybe it's not, because this would have to be 6, 5, because we couldn't put the 6, 3 there. No, maybe that is fine. This would be a 0, so this would have to be a 2 over here in that world. This doesn't work, I don't think. These were 1s in this world. I mean, this clearly doesn't work. I mean, this just doesn't work. Which is disturbing because it suggests my count is wrong, because these should add up, even if I wasn't able to. Okay, I'm going to pause the video, recount these, and then come back with a better count. Okay, I think my count was actually correct. I just made a mistake when I was sort of filling the things in because I still have 45 and 64 with the difference being 19. So I think the biggest that this two-sized equivalence region can be is 4. And if that were equal to 4, then I think this three-sized equivalence region plus these 3 void cells would be equal to 11. So let's just see if that works, if that blows it out. So these would be 4s. So we'd need, I think 3, 4 would have to go here. And then we'd only have one. Yeah, we only have one other 4. So that would have to go here. So now we only have 6 left to work with, I think, between this 3 region. So this 3 region would have to be 1s at that point. That would be required. And then down here, we could only have a total of 3. So this would go here. We'd need a 3 then here, which the only way to do that would be this. And then we'd need 8, 2. I can't tell if I think this is going to work. I think then this would need to be, no. Whoops, what am I doing? Wait, no, this doesn't work, does it? Does it? Let's see a way to make this work. That's frustrating. No, wait. 2, 2, and 6. That's 5. It does work. I should have done this so long ago. Okay, so just to recap what I did, and I should have done this ages and ages ago. I added up the total number of cells that we knew of who, whose values we know in the puzzle, and that included this 4-sized equivalence region because we knew those were going to be 3s. And then I added up the total number of pips and all the dominoes we have. And based on that, I determined there were 19. The total of the cells we don't know have to add up to 19. So that includes the 2-sized equivalence region, the 3-sized equivalence region, and then the void cells. And then it became clear that, if we put 5, if we use 5 or 6s in this equivalence region, we just get too high. The total gets too close to 19 right off the bat, and the rest of it doesn't really work. So 4 would be the biggest that could make that possible, and it turns out it was. That was horrible. I should have done that so long ago. Anyway, I'm very sorry for that abysmal solve. But those were the pips. Back tomorrow. Bye for now.